Hi everyone, and welcome to this tutorial on another naive model, which is actually just simple average. And this model is super simple. It's really easy to use, and we are going just to use it, and run our forecasts. So again, the data we are using is Amtrak data. We are trying to check and to forecast ridership of Amtrak trains, and the data we have is collected on a monthly basis, or was collected on a monthly basis beginning in 1991 and also ending in 2004 at some point. We have 159 rows of data. It's many years, and we split this data into a few parts. We have here the training set and also the validation set, which is smaller, just 3 years of data, and all the rest goes to this one. If you don't know how to do this, just watch the tutorial on simple naive model, and you will see how to import the data into SAS and how to split it into or partition the data, right, to create the training and validation sets. And you actually need to always do that, so if you don't know how to do this, do this. Now, watch that tutorial and you will know how to do it. Now, you will have to open a new program if you're doing it from scratch. To do this, you go here, program, and you have to run a libname statement, which is pretty much just directing SAS to the folder where you keep your data, and where you want SAS to record data in the process as you go, So you started with the libname statement, libname, then you give it a name. It can be any name, but don't start it with a digit, and also don't make it long. Try to keep it as short as possible. And also the path that you get and the address here, and just copy it and insert it into quotation marks, and remember to put a semicolon at the end. Just run it. Let me just run it, and you will see something like this in the log, that it was successfully assigned, which is a good sign. So you're ready. The simple average forecast is actually super primitive forecast. What it does, it takes your data, it takes all of your data points from the training period, and it calculates the average. That's all it does. And after that, we can use that, we can compare it to the actual data points and see our errors. We can see how far we are from the actual data, right? That's what we are going to do. This forecast we are going to be doing in a little bit different way, because we need to calculate the mean. And for that, we will have to run proc means data equals, and we're going to be using this set, the training data set, and we're going to find the mean of all ridership for these 123 periods in time, the data points. So we have this BSTA 477.set that is called Amtrak data TR. If you want just to be on the safe side, you go there, servers, local libraries, BSTA 477, find the set, right click on it, click on rename, Ctrl C, go here, Ctrl V, and semicolon. Proc means, now the variable we are going to be using, you can also write just var, I usually write vars, but doesn't matter, ridership, that's all we are calculating it for. And again, we don't need any printing, so we can just say no print. And you want to create a separate set, so we'll say output out, and will be mean, naive, for example, or let's call it naive mean, and all we need is mean and auto name, and let's just run it, and that's all. We are done, and this is our forecast for all periods for both training and validation sets. That's it. That's all we need, we only need ridership underscore mean, and it tells us that on average about 1,772,145 passengers ride on truck trains. Now we actually have to use this value to calculate all those errors and other things, but let's add this forecast to the sets that we have. So adding the simple average to the training data set. So to do this is actually it's not hard. We'll say data, we'll say mean TR, for example. This is the new set we are creating, and the set that we are going to be using is this one, BST 477 Amtrak data TR. I'm just gonna copy it. Done. Now we need to set the condition. If underscore n equals 1, then set, and the set that we're going to call is naive underscore mean. That's what we're going to create, and we can just run it, and that's it. And you can see that we have this added mean. We could have also done something here, you know, when we were creating this set, because we only need one value. We don't care about like the frequency. We could add, we could have added here the keep statement and the proc means. So when you're creating a new set, out naive underscore mean, you can use the keep, and all we need to keep is ridership underscore mean. That's all. So let's rerun it. We don't want to overload our sets, right? And we only have one variable here, and now we can just rerun this part, and you will see that only one variable will be added, which is great. You know, you don't want to overload your data, you know, your data sets. Yes, now we only have one, and now we can calculate all the errors and stuff, but we can also actually start with the basics. Let's add this forecast also to the validation set. Validation data set. And again, we'll call it data mean VD, set BST 477, and we are going here and track data underscore V. Oops. Close. Okay, good. Okay, perfect. So right click, rename, Control C. I forgot to click on this Control C. Track data V. So it's good that it was locked and I couldn't rename it. And so we have the set. Now again, if underscore n equals 1, then set, and we need the same naive mean set. And run. And that's how you use the mean forecast. Again, it's the same forecast for all these data points. That's it. So now all we have to do is we have to calculate those error terms that we calculated in the previous two tutorials. Again, if you know how to do this, you don't need to watch it. If you don't, so then definitely have to. So again, the errors are used to assess how good your model is by comparing the errors from the training and validation portions of the data. And also you need to compare models between each other, and you need to choose which model is the best of the best, you know. So that's why we need them. And we have the mean absolute deviation, mean squared error, square root mean squared error, and mean absolute percent error and mean percent error. And we are going to add all of these calculations when we are creating this mean TR set. I'm just going, guys, to copy what I have here. Let me just find it. Yeah, these values over there. So what we need, actually, we need to go we need to take a few steps. You cannot calculate it in one shot, unfortunately. So we need to calculate our absolute value here, absolute difference between the actual and the forecasted value. Also, we need to calculate the squared value of the difference, also the regular difference, and we need to calculate the absolute difference, proportion of the absolute difference of the actual and forecast values out of the actual data point, and just the regular, the proportion of the regular difference of the actual and forecasted values out of the actual data point. And that's all we need to do, and that's what we are doing here. So you can see abs, we have different variables that we are creating, and that's what we need to do. Let's rerun it. Let's run this section. What happened here? Yeah, okay, I see what happened. Instead of saying, okay, actually, you know what? I'm gonna go back, and instead of saying auto name, I'm going to use here one trick. We're going to call it forecast. Mean equals forecast, and you will see what it does. Okay, so this is again the proc means. It's not going to hurt the outcome. What happened here? Okay, because I asked to keep something else, I don't see my forecast, so let me just keep the forecast instead of that ridership underscore mean. Great, so now we have this forecast, and we can just rerun this section so that we don't have to change, you know, the forecast to ridership underscore mean, and it's really useful because it's going to serve a greater good. Now you can see that we have all of these values calculated for us. Now all we have to do, as you can see in these calculations here of the MED, MSE, and RMSE, and so on, we need to sum them up, right? So summing they're not errors yet, right? Some the residual values. Let's put it this way, and again we'll have to run proc means, but this time we're going to focus on summing up these values, right? So proc means data equals mean underscore tr. That's what we are using to sum. The variables we're going to be summing will be abs, will be div2, because we need to sum this. This is abs. Sum actual forecast, blah, blah, this is div2 to the power of 2. And also we need to sum the proportion, which is div underscore abs, and also this proportion, which is div underscore reg. And also we want to create a new set. We'll say out equals sum mean RTR. I know it's like a long name, but that's fine, you know, and it will be the sum statistics that we want, but here we'll use auto name because we have too many variables that we'll have to name, you know, so that's good if you have a chance to add a suffix to them. All of them will be called abs underscore sum, div2 underscore sum, and so on. That's what they're going to be called. And also we don't want anything printed, so we'll say no print. We'll specify that option, and let's just run selection. Let's go. Yeah, so we have all of these. We have the frequency. Actually, in this case, we are not losing any points, which is perfect. So now we can just calculate all of the errors, right? So finalizing error calculations. Training. You know, it's useful to know what you're doing, so it will be data mean RTR. I guess it's possible that I called something. Okay, so no I didn't. Okay, so mean training errors, and the set again that we are going to be using is this one, mean TR. Okay, so this is the set min tr, and we do not need much, but we still need to call these values. Okay, so if so if underscore n underscore equals 1, then set, and we have to, sorry about that, we have to use this set that we just created, sum min rtr. And let's run, let's see if it worked, and after that, if it did, then we'll calculate other stuff. Yes, it did. You can see again we have the same value for all of these values, for all of these variables that we were adding, like abs sum or div2 sum, but it's fine, we're gonna subset the sets later. Now let's go here and let's actually keep calculating. So let's create this variable n underscore n equals underscore frac underscore. We could have done it before, but doesn't matter. And now we have med and MSE, RMSE, and MAPE and MPE. So the med calculations will be abs underscore sum over n. The MSE calculations will be, if you remember, div2 sum over n. The RMSE will be the square root of MSE. This is easy. Now MAPE is going to be div abs sum over n, and the MPE will be div reg sum over n. And also because MAPE and the MPE, they are in percentages, so we have to apply the format. So we'll use format and the names of these variables and percent 10.2, and that's it. It should work. Let's check. Okay, and yes, it did. Great. So now we will also need to do something else. We could actually do it even here. We could say where, and we could say that our date is equal to 01 Jan 1991 D. So let's see if it works. Something is wrong. Maybe incomplete. Okay, so min maybe incomplete, but okay, I see. It's because I used no, that's not because of that. Okay, so where equals date blah blah blah. Okay. Now it's complete. So we have all this data, which is perfect. Now guys, we're also going, I'm just kind of taking this one step off. So keep, and all we're going to keep is n, med, MSE, RMSE, and MAPE, and MPE. And that's perfect. Yes, we have it. Now we're going to do pretty much the same thing for the we have this for the validation set. Let me just go down there, and let's add this information to the validation set. Let me just rerun it. We do not need to type it again, there is no need. We don't need to change anything. Everything is perfect. Everything is pretty much the same. And again, we'll have to sum up the residual values in the same way, and we'll have also to finalize the calculations. I'm gonna just copy and change the things as needed. So summing the residual values, let me just add here that this is validation so that we do not get confused. And the data that we're using for the proc means, now we're going to sum these values, and we are taking the original set mean VD, not training anymore, VD, and here we'll also change some mean R. Instead of TR, we'll have VD, and again sum auto name. So we can rerun this one. Not rerun, but actually we are running it from scratch, kinda, but not exactly from scratch. Yes, we have everything that we need. And now we could go here, and we'll do the same. So it will be mean error, but not train, but validation. We're going to keep the same variables. We are going to use not mean TR, but mean VD. Some mean error VD. Our date now can be, I think, the 1st of, let's check. And that's, let me just rerun this one before. Mean VD. I just want to check the date, because you know I have a really bad memory, so it's really good to check it. Yeah, so this is April 2001. Okay, perfect. So let me just specify it here. Wait, sometimes it's 2000, sometimes it's 2001. Interesting. Okay, so this is what we're going to say. 01 April 2001 D, and all the rest is the same. Mean error validation, the new date validation. It's perfect. Great, so now this is what we have, and now what we can do again, we can go to tasks, we can go to task data, append table, and add also the training. Sorry, this is not we'll go to the work library, and we need to find mean with error TR. Great, and again we have to move it, and in the results we are going to create BSTA 477, and it will be mean errors. Let's run it and let's see what we have. So perfect, we have now these two sets, and we can see actually that there is some distance, right? But still we could observe the highest distance when we were running naive, let me just find naive errors, like simple naive forecast was the worst so far. This model is not good anyways, so you know this is not the model to be used. We also have seasonal errors. This was much better because the distance between the training and validation sets was much smaller than for the simple naive. Now we also have the mean. Let me just refresh this data. I just want to use that last data set we created. So we also have mean errors, and we can see that it's worse than seasonal naive. It's not much worse, but it's still worse. And that means this model maybe is not good. So if we had to choose among these three models, we would actually go for the seasonal naive, because there we observe the lowest errors and also the lowest distance between errors, which is great. So here if we compare, if we check the for the rigidity of the, not rigidity, but how model is stable, how solid the model is, then you will definitely go for the seasonal. Right now we will definitely have better models, I'm sure. But yes, this one, you see, it has the lowest distance between the training and the validation sets, but also it has the lowest error terms among all of the models for both training and validation sets. So this model is so far the best.